Good evening, class CIS 476. My name is Ronnie Kina. Today I'm presenting one of the design patterns that we didn't cover in our course, Software Architecture and Design Patterns. This design pattern called Dependency Injection. So as we all know, the design patterns, they're classified in three different groups or three different categories: creational, structural, and behavioral. So the dependency injection falls under the creational classification. Okay, so what is dependency injection? Dependency injection is a technique in which an object receives other objects that it depends on, called dependencies. So that what Wikipedia says about dependency injection. And another definition I found was on the website Stack Overflow. They said dependency injection is basically providing the objects that an object needs, which is its dependencies, instead of having it construct themselves. One of my favorite definitions was by the author James Shaw. I found it in his book, The Art of Agile Development. He said that the dependency injection is given an object its instance variables. So let's see what he means by that in the next slide. Okay, so think of a computer, for example. So to be able to make the computer run properly, the computer gonna needs its components. So you can't, the computer cannot run without the CPU, the processor, the RAM. Where can you store the data if you don't have the hard disk drive? To even power on the computer, you can't power it on without the power supply. Same thing with the fan. So the computer depends on these components. So these components are the computer dependencies. If we think of this computer as a class in programming, so we can either create a single component in the computer, or we can create these components somewhere else. So let's see. Let's take a look and see what happens if we create them in a computer class. So if we create each component in this computer and inside the computer class, this would mean that every single computer we create, it will have the same specs. So if we try to change, like let's say I have the Intel i5, if I want to upgrade that to i7, that means all the computers that I'm going to create next, they're going to be i7. But we don't want this. So we want to be able to have each computer have its own specs, and not all of them look the same. So that's where we're going to need dependency injection for that type of situation. So that would be our motivation. So the primary purpose of the dependency injection pattern is to allow selection among multiple implementations of a given dependency interface at runtime, or via configuration files instead of at compile time. Applicability. So here are several common situations in which the dependency injection pattern is applicable. So we need to inject configuration data into one or more components, inject the same dependency into multiple components, inject different implementations of the same dependency. Also, we need to inject the same implementation in different configuration. Some of the services provided by the container. So there are more situations where dependency injection can be applicable, but those were most of the common ones. The structure of this pattern is pretty straightforward. This pattern contains of three classes: client, service, injector. So the client that depends on the service it uses these services. So the client is the dependent here, and the service is the dependency. And here the injector, what it does, it injects these the dependency into the client. So that's the structure of of this pattern, dependency injection. The participants are the class, the client class. So the client class is the dependent class, depends on the service class, as I showed you earlier in the previous slide. The service class is the dependency class that provides service to the client class. Injector class is the injects the service, the dependency, into the client class, which is the dependent. In this way, the dependency injection pattern separates the responsibility of creating an object of the service class out of the client class. And we'll be able to see that in the code demo next. Consequences. So the dependency injection is just like any other design patterns. It has pros and cons. But one of the main benefits is that it reduces class coupling. So if the classes are coupled, like dependent, so it decouples these classes. Also increases it increases code reusability, improves code maintainability, improves application testing, centralized configuration. However, the main drawback of dependency injection is that using many instances together can become a very difficult if there are too many instances and may depend and many dependencies that need to be resolved. Known uses. So the known uses, it's usually used for unit testing. And unit testing dependency injection enables one to replace complex dependencies such as databases with mocked implementations of the dependencies. This further allows allows them to completely isolate the code that is being tested by the team of expert testers. Validations or exception management. So with the assistance of dependency injection, and an individual can inject additional code between the available dependencies, which is great, of course. Implementations. To implement this pattern, there are three methods to implement dependency injection. Constructor injection, which is the method that I used in that demo code. I'm going to show that to you in the next few slides. The constructor injection, the injector supplies the service dependency through the client class constructor. Property injection, also is known as the setter injection. The injector supplies the dependency through a public property of the client class. Method injection, and this type of injection, the client class implements an interface which declares the methods to supply the dependency, and the injector uses this interface to supply the dependency to the client class. All right, so this code, this demo code is without using dependency injection. So let's see how that looks like. We have the computer class, which is the dependent, and we have the component, and we're just using the class to this the app component. This is just a class used to display the component added. So it's a pretty straightforward code, very simple. Component has setters and getters. So we pass the component that we want to add to the computer through here. So that's that. So by creating this type of this type, that means like every computer we're going to create, it will have the Intel i5. So if you want to change it, that means all all the computers will be changed. So that's where we're going to need to use the dependency injection. It'll solve this problem for us. So this code showing how we implemented the this pattern, the dependency injection. So again, we have the computer, which is the dependent, the component, which is the dependency. So here where we use the method, so we're passing the component through the constructor, the computer constructor. And as you see here, we can create like many computers with different specs. We can without the need of creating a different class. So we keep using the same. So we keep creating computers, and each computer will have its own specs. So as you see here, I upgraded the processor, the hard disk drive. Instead of using Western Digital, I want to use the Seagate. Same thing with the graphic card. Okay, so that was the code for dependency injection, and this is the output. And references. So I gathered I learned a lot from this pattern from James Shor's book, The Art of Agile Development. Also Wikipedia and Stack Overflow. This was a very, very useful website. Okay, thank you all for watching this presentation. I hope you liked it. Thank you and have a good one.